Hi, this is Yogesh.
From this lecture till 46th lecture, we'll talk about the dependency injection. So I divided the dependency injection topic into 5 parts. So in this lecture, I'm going to cover a dependency inversion principle, that is a DIP. Then we can see what is the tight coupling, and we'll also discuss about the IOC, which is inversion of control. So before going to the dependency injection, we need to start with the dependency inversion principle, that is DIP. So the principle say your high level module should not depend upon low level module, and both should depend upon abstraction. Now what is the high level module and what is the low level module? So let's quickly move to the next slide. So this is my high level module. So let's say I have a class called high level. Inside that, I define one method called get data from service, and the return type of my function is list of type string. And here I am creating one object of service class. So service class is my low level class, and this service class has a one function called get data, which is creating the list of type string, adding some dummy strings and returning to your high level class. So again, in a high level class, we create the object of the service class and we call the get data function and getting the result. So point over here is your high level class is this and your low level class is your service. So normally we have a high level classes, always call some services, and from the services we will get the data. So the principle say your high level module should not depend upon your low level module, both should depend upon the abstraction layer. So what does this mean? Here I am creating the object of the low level class inside the high level class. So that's why the dependency is created on high level class for your low level class. So the principle say don't create the object over here or don't create a dependency. You need to depend on one abstraction layer who create the object of your low level class, or I can say a dependency. So back to our slide. So DIP help us to develop the loosely coupled code by ensuring that high level module depend on abstraction rather than concrete implementation of lower module. When I say the concrete implementation, means here I am creating the concrete object of a low level class. So instead of creating the object inside the high level class, we'll create a one class and create the object of your low level class or a dependency. Let's move to the next slide. So here in the main function or in the main call, I'm just creating the high level class object and call the get data from service, and the console.write line say tight coupling because my high level is depend upon low level and we are getting this output. So let's see in the practical. Here I'm going to create a one console based application called DI. Let's add two classes. One is the high level and low level. So add class high level and say service. This is your low level class. Normally we call this is the dependency. Let's add one function inside your low level class. So this is the get data function. Inside that I am creating a one list of type string and adding the YP, KP and the JP data, and finally I am returning this list. In the high level class, let's add a one function called get data from service, and here create an object of your service class, that is a low level class. Obj service is equal to new service and call the function obj service dot data inside the list of type string, and finally return this lst build. So here I can say we have the tight coupling. because my high level class is depending on your low level class. So here I am directly creating the object of a low level class inside the high level class. Here we call the high level class object, call the get data from service, and one by one we display the names. Say console.readline, put a breakpoint and check. So here we are creating the object of your dependency, that is a low level class, and then we get the data and display this data inside your console window. So this is called a tight coupling. Okay, so now we know what is the tight coupling. Now we know what is the DIP principle. Now let's talk about the inversion of control, which is normally called a IOC. So this is the programming style where the framework or a runtime control the program flow. So IOC give you some way to implement the DIP. So if you want to make the independent of your higher level module from the lower level module, then we have to create an abstraction layer so that your high level module is not used to creation of a object. So IOC, that is the inversion of control, give you, or it's providing the way to create the abstraction layer. So if you see the diagram, so this is your high level module and this is the low level module, and inversion of control, this is the one programming style, will allow us to create the abstraction layer. So finally, the DI and the service locator pattern are specialized version of IOC pattern. So inversion of control is the design pattern, and there are some two techniques to implement the abstraction layer. The first one would be a dependency injection, and the second one would be the service locator. So in the next lecture, we can see what is the dependency injection and how to implement the abstraction layer to avoid the tight coupling. Okay, so in this lecture, we talked about what is the DIP, that is Dependency Inversion Principle. Then we talk about the tight coupling, and finally we talk about what is the inversion of control, that is IOC.
Thank you for watching.